Hi, EFR 516 students. This is online assignment, exercise number 2, and this is the example. So I'm going to work through an example here, and then you have to do the actual assignment. So we look at this. This has 3 problems, and the first problem says run the simulation for 20 observations, report the mean, standard deviation, and standard error for this data. Then calculate with SPSS the 95% confidence interval for the mean. Note, every time that you run the simulation, you will get a different random set of data. So you're going to simulate some data here. So the standard error and the confidence interval are dealt with in chapter 2 of our text, the Warren text. Okay, so what we need to do is we'll go ahead and block and copy this syntax from the assignment. So I'm just going to copy that, and I'll bring it over to SPSS. So start your SPSS. When it first comes up, it'll look like something like this. You can close this first window and go right to the data window. Okay, so from the data window, we're going to go up here and say File, New, Syntax. We're going to open a syntax window. Syntax. And right here is where we're going to paste in our code for the simulation. So we can go ahead and run this. We'll block and run this. Hit the green triangle and it runs it. So it ran it, and then what it did is it created our data here in a data file. So it created the data, and here's a histogram of that actual data. So now what we want to do is go and calculate the standard error. So to do that, I'm going to go up to Analyze, Descriptive Statistics, and Descriptives. Analyze, Descriptive Statistics, Descriptives. Click on that, and then I'm going to bump over X. That's the variable I created. And then I can look at my options, and we see the mean, the standard deviation. We don't need the min and the max, but we need the standard error, right? The standard error is the standard deviation of the means, and it's calculated as the standard deviation divided by the square root of n. So I'm going to click on standard error. I'll say continue, and then I can say OK, or I can say OK, it'll just run it, or I can say paste. And when I go to my syntax window, it's going to be there. The codes for it's right there. So if I run this code here, I block it, and then I hit the arrow, and there it's calculated my standard error, my standard deviation, and my mean. So that's the first part of this problem. The second part, it's asking for the 95% confidence interval for this. So so let's go ahead and do this. So I'm going to go back to my SPSS. I'm going to go up to Analyze, Compare Means, and say One Sample T-Test. I'm going to bump over that X value that I simulated. I'm going to go Options. Okay, so it says confidence interval, percentage. Again, the default is 95. That's what we want. So I'm going to say Continue, and then I'm going to say Paste. Now I pasted it, the syntax window's open, so I'm going to come down to my SPSS symbol. I'm going to go to that syntax, and here it is right here. So I'm going to go ahead and block that. And this has given us our confidence interval. So right here we see that the mean value is 43.23, and its 95% confidence interval is from 33.6 to 52.86. So that's our confidence interval as shown in chapter 2 of the text. So that finishes it for this one. What I can do, I can just grab this table right here. And again, when I'm going to copy these, I'm going to copy them as a meta file, so I don't have any size problems when I come over. So I can just copy that. I'm going to bring that over to my assignment. I'm going to paste it right in here. So that's the standard error part. And then I'm going to go back and I'm going to get the 95% confidence interval here, right here, copy, paste it, and that satisfies this assignment. The standard error and standard deviation and the 95% confidence interval for that. Okay, so now we'll move on to number 2. Okay, it says run simulations for 200 observations, report the mean and standard deviation and the standard error. So notice that the simulation in the first case went to 100 or to 20, and the simulation for this one's going to 200. So I already have 200 in here. So I can just go ahead and grab that. I'm going to bring this over. Or, in fact, I could just use the code I had in there. Why don't we do that? It's code the same. We're just going to change the code we already have in the syntax window. So I'm going to go to the syntax. So right here it says 1 to 20. I'm just going to make that a 2. So 1 to 200. And then it's going to give me the other calculations that I just did. So I'm going to block the entire thing, and then I'll run it. Now this is an advantage to using the actual syntax and running it from there instead of just hitting OK. So here's our data plotted, and here's the standard error and the standard deviation, and here's my mean and confidence interval. So I'll go ahead and copy these over. Now notice that it's still defaulted. When I copy it, it's still defaulting from a meta file. So I'll say OK, and I'll bring it over to my assignment, paste it in there. And likewise, the confidence interval. Okay, so we'll go back up to this problem. It says, then calculate the, with SPSS, the 95% confidence interval. Now compare your 95% confidence interval with the first problem. So if we grab these, if we look at this confidence interval here from the first problem, I'm going to bring it down and compare it with my confidence interval from the second problem. Here it is right here. So the first one simulated 20 observations, and the second one simulated 200 observations. So again, the first confidence interval was 33.6 to 52.8, and the second one is 46.23 to 51.8. So you notice the confidence interval is much smaller than the first time, right? So, and why is that? Because the confidence interval is calculated with the standard error, and the standard error is the standard deviation divided by the square root of n. So as n increases, we can kind of measure the precise value of our mean more precisely. So, and that's what's happening. As the sample size is increasing, we're getting a more precise observation from our mean. And that's the answer to that, right? So comment on the size of confidence intervals. You might it might be different. So you're going to write there that the mean for the confidence interval for the larger sample is smaller. That's what I'm looking for. Okay, then number 3, run a simulation of 10 observations for the two variables x1, x2, then calculate the 95% confidence interval, the mean difference between the two samples. Note every time you run the simulation, you're obtaining different data. The population difference from the simulation is 60 minus 50. So as you see here, we're going to create some random variables. I'm going to create 10 observations. As you can see, there's 10. And the x1 is going to have a mean of 60. x2 is going to have a mean of 50. So we want to know the confidence interval around that. So Now notice that we're going to create uh, uh, two columns of data, such as dependent tests. So we're going to go ahead and grab the code, copy that over, bring it over to my SPSS. Now I can leave the first code that I had. Just going to put in the new code right here, and we're going to go ahead and run that. Okay, so that created two variables, an x1 and an x2 right here. Created the two variables. And to look at a confidence interval for those, I'm going to come up and go analyze, analysis, compare means. We're going to look at, these are two columns of data. So I'm going to look at paired samples T. Here are our two means. I'm going to bump both those over. I'm going to say paste. Then we'll go to my syntax. Right here. So here's, I pasted the test. I'm going to block this whole thing and I'm going to run it. Okay, so it gave us a paired test. We notice the mean difference is 59.48, 60.57. So we want a confidence interval for that. So it's right here. It's minus 16.12 to 13.94 is our confidence interval. So I can go ahead and just grab that, copy that over. I'll paste it into my assignment. Okay, and that's our confidence interval. And as the text notes that we can get confidence intervals for many different types of things. For example, an independent sample test or other measures, we can figure out our confidence intervals. So this is what I want you to do for the assignments. And if you're interested in learning more, you can go ahead and manipulate the sample size. And here's the standard deviation you're simulating. So what happens if the standard deviation gets larger? I would tend to get a bigger confidence interval. If it gets smaller, I tend to get a smaller confidence interval, and or the sample size. So if you want to go ahead and play with this, you can look at what happens to your confidence intervals. But this is the assignment I want you to upload, or the answers I want you to upload for the actual assignment. Again, this is a sample. You do not upload this sample. So thank you.